Welcome back. In the previous session, we talked about XGBoost. In this session, we're going to combine all of our models that we've looked at since decision tree and apply it to the project HR, the HR project that we looked at previously. Just to refresh your memory, this is what the HR project looks like. Basically, we have 1,470 data points and 35 features. We narrowed down what we wanted to actually use as our features, which are these. We ended up with 31 features, and we removed, we actually have Y, rather the attrition, staff attrition stored in the Y variable. Okay, and we actually changed the yes no to 0 1. Okay, now what else? In terms of the other things is that we have converted all of the so-called categorical variable, and we have converted them to 0 1 one-hot encoding. All right, having done all those preparatory work, we applied the decision tree with it, and basically first of all we split it into train test data. We applied the decision tree, and what we got in the end is it's a fit perfectly within sample, but the average accuracy score is 76%, and the out of sample is 79%. Right, having done that, now what we're going to do now is that we're going to start first of all into our ensemble model, number one, which is bagging. So let's import our tree, which we already have done that. So we're going to import our ensemble, and we're going to import our bagging classifier. Okay, so our bag classifier is equal to the bagging classifier, and with the base estimator is equal to the classifier. If we remember, yep, CLF, correct. And the number estimator, we're gonna change it to 5,000, and the bootstrapped is true. The number of jobs, we're going to use all the cores, and the random state equal to 42. This needs to be small cap, otherwise it's going to get an error. Number of jobs, okay, number of jobs is -1. Okay, all right, that's gone through. Okay, so the next thing now is to fit CLF, fit our model, X train, and also Y train. Okay, while it's running the fitting, that might take a wee while. We're gonna start to print our score. All right, so this is the in sample training, and also back-to-back the actual performance with our test score. So let's have a look at the bagging. In sample is good. The accuracy is 76. 7640 hasn't improved. In terms of the out of sample accuracy, is 7935, so it hasn't improved much, unfortunately. So that's okay, at least we gave that a go. So now let's try random forest. Okay, so now random forest. So we're gonna from scikit-learn ensemble, we're going to import random forest classifier, and the random forest classifier is equal to random and random forest fit X train and Y train. Okay, that went through. All right, so now let's copy these and let's have a look. Okay, 7640, well, not much has improved there. All of, let's see, CLF, well, I'll tell you why, because we need to change this to RF. That's the danger of doing this. Okay, and this one we also need to change the bag. That would explain why. No change. So let's have a look. accuracy score still 1. All right, let's see. In terms of the cross validation, we did the tenfold cross validation. I think if we remember, yep, tenfold cross validation here. Alright, so the accuracy score has improved substantially when we compare it to the decision tree. So that's actually a bonus for bagging. So let's have a look at random forest. Okay, so we change it to random forest. So let's run this. Okay, 98. So 85/30. 85/30, so not too dissimilar in terms of standard deviation. Is almost there. Accuracy score 80/51. So the bagging has improved. It's better than random forest, but random forest was really fast in terms of the way that it ran. So that was actually also a very good result as well. Right, coming back to random forest now. We know that the result was pretty decent because then it ran so fast as well. So let's just import Seaborn because I wanted to look at the significant features. Set style, no, we just won't worry about that. Series and the random forest classifier and the feature importances, and our index should be equal to our xtrain columns, and yep, and then we do want to sort this from small to large, ascending is equal to true, and we want to plot that out, and we want it to be a bar chart. And finally, set the figure size is equal to 12/6. Right. Let's just make it false. I'm more used to looking at it this way. Okay, there we go. Monthly income's the most important, followed by distance from home, and on it goes. The last is actually the education field itself. So that's useful. All right, having done that, so let's move on to the next model, ADA boost. Okay, so again from sklearn, we're gonna ensemble, we're gonna import ADA boost classifier. Okay, and ADA, the classifier will be equal to ADA boost. Just instantiate that. Now I realize that I am not using the optimal parameters or hyperparameters. I think that's okay because right now what we're really trying to do here is actually just run through all of the different models at the first cut, see how well it performed, and that's really the benchmark that we want to look at. Okay, so now let's look at how well ADA boost runs. Okay, 85/48. Wait, again, need to change this. ADA. Okay, Okay, there's an error there. So let's just run that again. 90, 86, 38. That's improvement from random forest 86. And it's also an improvement to bagging classifier of trees, decision trees. Okay, so looks like error has performed. You notice that because we use more data, now the so-called more advanced model, the more recent model is actually seems to perform better and better, and they seem to be able to actually really outshines those that has come before, which is what we were expecting, and it wasn't showing really when we were actually doing it with the Titanic data. With there wasn't a lot of observations. Now there's one that we did earlier, which is add a boost plus random forest. So let's try this again, and let me just instead of having you watch me, so I'm gonna do this from what we actually did do. So just change it to Revel. Okay, so that we don't have that. So now let's run these and look at the cross-validation score to see if it has outperformed 8638 with 2.3%. 86, no, it hasn't actually outperformed, but that's okay. At least we actually gave that a try. Okay, so let's look at the next one, which is gradient boosting classifier. Okay, let me push this up the screen. From sklearn ensemble, import gradient boosting classifier. Okay, gradient boosting classifier, gbc underscore classifier is equal to gradient. Yep, and we're gonna fit that gbc clf fit our x underscore train and y train, and revel this fit, not foot, fit. Okay, right, so let's look at the result now, or how well gradient boosting classifier works. Right, so it's running the cross validation, 10-point cross validation, or tenfold, 8560, 8560, 8530, 8521. So it hasn't actually improved much. Standard deviation score hasn't actually improved much either. So now, finally, we are going to look at our XGBoost. Okay, so import XG as XGB. XGB fit is equal to, I need to underscore this, GB XG classifier, and then I'm going to just leave it as that. Not even going to specify. And we're going to fit, should really call this classifier, not fit, CLF, fit the X train, and also Y train, Revel. Okay, right, let's have a look. This is, oh, well, we did that again. GBC. Did we do that with error? Okay, that one's fine. 87. Sorry about that. The gradient boosting machine did improve 8711 to 8530, so it has indeed improved. So by now you're probably screaming at me, get that sorted out. So let's copy this so that I don't irritate you. So let's have a look at gradient boosting machine 8665. It's not the highest, but it's pretty decent. It's one of the best. This is again before tuning. Accuracy score is it's also up there. Not as great, but it's pretty decent. I think what we've learned from all of these is that, hey, in the first cut, we can pretty much tell that XGBoost and along with the gradient boosting classifier is the cutting edge technology. Without much tuning, basically didn't even specify any hyperparameters, it's already performing the best. Add boost with random forest and add boost with trees can do well, but it probably require a fair bit of tuning compared to the two more recent gradient boosting machine, as well as the XG Boost. But at the very least, though, what we have found is that Adder Boost is very good. Gradient boosting machine is also very good. XG Boost is also very, very good. Now, that's pretty much the end of my demonstration part. I think I've left you with a lot of homework to do. Well, the homework now is really this. Try tuning the parameters to see if you can actually come up with a score that far exceeds 86% or 87% accuracy score here. So that is really your task. So pause the video, go and try it out. This might take you from anywhere from 10 minutes to a couple hours, maybe even a couple of days if you actually start really tuning it. Now this is an art. This is the part whereby I can't tell you how best to do this. It does come with experience. As you do more of these, you actually start to get better at this. And in fact, when you really look at all the Kaggle competition, getting this part is very easy. I'm sure by now you figure out, hey, he keep repeating the same process. It actually seems to be very, very similar. The part that gets a bit complex is, or rather require a lot more work, is the feature selection, feature creation, feature, and also the tuning part. Yes, a lot of our task is actually on the tuning part. And I'm sure you remember in terms of the XG Boost lesson, we talked about fitting or optimizing it. But we also need to look at the regularization. Don't allow our model to become overfitted to the actual training data, that it cannot generalize to out of sample data. So that part is really important. So pause the video now. When you come back, I'll summarize the lesson. Welcome back. I hope you gave it a real decent try looking at the HR project itself. In this lesson, what we've done really is that we took the human resource analytics and we actually basically did a prediction exercise to see which staff is likely to suffer from attrition and which one not. We were basically fitting. We first tidy our data and also pre-process our data so that it's numerical rather than, or categorical rather than it's in text or string format, which scikit-learn will not be able to manage. And we started fitting decision tree, bagging of the decision tree. We did random forest, we did adder boost with random forest, and then move on to gradient boosting classifier, XG boost, and that's pretty much the whole process or flow that we actually did. I hope you find this whole lesson enlightening. I didn't dig into the numbers too much, but if you really look at this carefully, you should be able to notice something that's really quite, the word that I would say is troublesome. That's what are the troublesome part. That's the recall. You notice the recall if you look through all of the performance of every model. Although the average is high, the recall is quite low. And the reason being, let me show you now. Did I actually do a calculation early on here? Okay, I'm gonna just show that here. So look at the Y itself. Y value count, values count, value. Oh, okay. Y is no longer appended series, so we have to use df attrition. So let's use this and come back down here. Value counts. Okay. Looks like it's been deleted. df, let's have a look at df. Is it still there? Okay, df is already been removed. So what we'll do here is, let me just rerun this. Okay, re-download the file. Attrition is still there. Okay, so this part, this part, this part. Okay, what I will do one is create another one here, which we call temporary, is equal to that. Okay, so we store TMP, and we delete this, and what we do one is fit transform TMP, and we store TMP. Okay, so first of all, let's look at what's TMP. Okay, it's a numpy, so we're gonna change it to pandas so that we can actually make use of some of the function. Must be a panda series TMP. Data must be one dimensional. Okay. All right, so we'd have to change this to a list. Okay, so that's fine. All right, so now let's look at the value. So finally managed to show you this now. Value counts. Okay, right. Hopefully you see the problem. I've talked about this before in the past. You might not have noticed it. TMP sum. Okay, let's just do this. Total is equal to TMP.sum. Okay, so divide this whole thing by total. 5 to 1. What is the value of total? 237. Oh, okay, right. That's the reason why. So we're counting. Okay, that's better. Because if we sum 0, obviously going to sum to nothing. So if you look at this, right, 84% of the observation is actually 0. 16% is 1. And when you have an unbalanced class problem, this is always going to have come up again and again as a problem. And this is the one key thing I want you to take away, is that when you are dealing with an unbalanced class, the machine learning is going to struggle with that. So you have to actually treat it slightly differently. So when we come back, we're going to go into a different topic. I'm going to show you how to do ensembles of ensembles. While we've already done ensembles, let's go deeper. I know it feels a little bit like Inception, but trust me, you will find that the lesson will be enlightening and quite exciting, if I may say so myself. I look forward to seeing you in the next lesson. Thank you for watching.